recording. So first of all, one of the primary ways that we can use an operational amplifier for our purposes is that we can use the current output from an operational amplifier through a relay switch, which can in turn operate a further high voltage connection. This is the typical circuit symbol for a relay switch. This rectangle represents the solenoid, and the switch should always be open on the further side. This switch is usually made from soft iron material, and the solenoid is a basic coil of any material, doesn't matter. Whenever current flow does happen through this coil, this becomes magnetized, and the attraction of the solenoid causes the soft iron switch to close, and vice versa. When the current flow stops, it will not do the it will not provide the connection. Now there is a catch. We would want this relay switch to behave differently for different type of outputs. So one of the key uses for operational amplifier is, other than the amplification, is the this circuit. This is the comparator circuit, so by which it actually detects the voltage level for two different type of physical scenarios, depending upon whatever the input device we apply over here. We can detect between multiple different variations. So this op-amp will always give us a saturated output, but it can give us a positive output. Alternatively, it can give us a negative output. Now, in some cases, we would like the positive output to energize our solenoid. In some other cases, we would like the negative voltage to energize our the relay switch. So, depending upon how we want this solenoid to be energized, we can choose the connection type of diode, because a diode is the type of device which can allow the current flow through the circuit in only one direction and stops the current flow in the other direction. So here is a sample connection for one type of diode connection, and I'll explain this part in detail. So bear with me. This is the type of diode connection which is gonna provide us the closing of this relay switch for one type of output. So this diode D1 is the primary deciding factor which is gonna allow the current flow, conventional current flow, in this way. So what this means, that whenever the op-amp output will be positive, and this is ground, which means this is the high voltage connection, this is the low voltage connection, current can actually pass through the diode without any obstruction. Considering ideal diode, the solenoid will be energized, switch will be closed, and whatever device, loudspeaker or signal lamp, or maybe both you have connected over here, that will work. Or it can be an automated switch for other components as well. So this diode will allow the op-amp to provide the relay switch for a positive output. Vice versa, if there is a negative output for the op-amp output, then this will become the negative, which is the lower voltage. The ground would still be 0 volt, which is the higher voltage. So current will preferably try to go through here, but it cannot, because this is the diode. This diode will stop the flow. So by applying this diode, we're only making sure that this solenoid will be energized. Energized means it will become magnetized. It will be energized only when the output is positive. So only one type of output will cause this diode switch to the relay switch to work, and whatever connection that you have provided on the endpoint, this will essentially perform its task as well. Now, interestingly, we would require, for the safekeeping of this diode, we would require this second. There is a secondary diode over here as well. This is called the okay, no, it doesn't have any name. There is a secondary diode that has to be connected over here to stop the back EMF. Now, the back EMF is a absolutely new thing for you, which we never have discussed. I'll explain the idea of back EMF for this circuit in detail. So I'll just take this picture out. Just give me a second. Okay. Remember Lenz's law. What Lenz's law essentially gave us is that whenever current flow will happen, it will always happen. Whenever electromagnetic induction will happen, it will always happen in such a way that the region of the EM induction can be opposed. Now, here's the deal that I want you to understand. First of all, actually, let me copy paste multiple iterations of this, because we might actually need multiple of these figures. So the primary idea is, whenever this is positive, current flow will happen. This will energize, let's say energized, and this will close, and whatever component that you connect over here will work, and vice versa over here. Now, the reason we need this diode is because of one thing. Whenever this coil will be under the effect of a fixed EMF supply, or let's say it is now, let's say it is, there is a certain magnetic field that is going around this thing. Now I want you to understand this thing very clearly. Whenever this op-amp output will swap from positive into negative because of the change of the sensing device, which can be the comparator circuit input from the LDR, or for the thermistor, or for the piezoelectric transducer, or for any other devices. Whenever this positive output will switch to negative output, this current value will very soon, very fast, it will reduce to zero. But for ideal components, we consider that this current flow reducing to 0 ampere will happen instantaneously. But in true case, it doesn't happen actually instantaneously, because the electrons were actually flowing at some speed, the transport equation that we know, I equals to NAVQ, and for the current flow to absolutely stop, the electrons have to decelerate from that speed to zero velocity to stop the current flow. Now, this is the thing that will happen. Whenever this solenoid is energized, there exists a certain orientation of magnetic field lines that pass through this coil, and there is a magnetic field around this thing. As the current flow will start to reduce, this current flow of this coil itself will slowly start to make this coil lose its magnetism. Important bit. The reduction of the current flow will slowly start to make this solenoid lose its magnetism. Now, because by Lenz's law, it says that whenever electromagnetic induction will happen, it will always try to oppose the region of electromagnetic induction, which means because this is a solenoid, as the coil will start to lose its magnetism, it will preferably try to maintain that original magnetic state and try to create its own current flow so that this coil would not become magnetized. This is very much similar to, this is not exactly identical to, but it is quite similar to what we have seen in the electromagnetic induction. Electromagnetic induction core idea chilo je if we have a solenoid coil, we bring up a north pole close, and then it will repel by producing a north pole over here, which means this will not appreciate the change of the magnetic field around this thing. So whatever the magnetic state of this coil is, this coil will preferably try to hold on to that stage. Whenever we are trying to bring in the north pole, then that variation that is happening, that ongoing variation will be repelled by this coil by producing a current through this solenoid coil. Now, in the similar manner, but not exactly in the identical manner, this solenoid will try to keep its magnetism intact. So as the current flow will drop because of the opposite voltage getting because of the output getting reversed, this solenoid will try to produce its own current, which means it will try to maintain its magnetism. Have a look. This is the important bit. In this case, this coil became magnetized because the conventional current flow that was happening downwards. Because of a conventional current flow that was happening downwards. So this coil will try to maintain this current within itself, and this will only happen as long as the current starts to keep on falling from I to 0. So this is a very small period of time, but within this time, depending upon how many number of turns of coil do we have over here, this coil can produce an momentary high EMF, where this EMF will try to maintain this current downwards. So according to this coil, what this coil will try, this will essentially try to pull this current, a very large current, through this thing. Now, problem that can happen, that you have to understand that this is the op-amp output, which means on the left side of this op-amp, we have the actual op-amp circuit. So this output is essentially coming from here. Let me show you a reference. Mouse কোথায় গেল আমার? সমস্যা? আচ্ছা, my bad. This output of the op-amp essentially represents this thing. So this is the output of the op-amp, which was connected to that circuit. So if I just take this circuit part out, let's say from here, sorry. Okay, let me put it out. So all right, so this is the part that I want you to understand. This output that you can see for this op-amp circuit, I actually shrinked it a little bit to accommodate it within the space. This output is connected over here, and this is essentially operating this solenoid to work out. Now, because this solenoid would not want to become demagnetized, it will produce a momentary high EMF so that it can maintain that current. This is what we call the back EMF. This back EMF is a very small EMF. So it's a very short-lived EMF, but it can be of a really high value depending upon the number of turns of this coil, which can essentially be a problem for our circuit, because let me show you why. This solenoid will produce a pretty high voltage for a short duration, and if we do not have this pathway, then this solenoid will essentially pull this whole current through this part. Now, if large current has to pass through this part, then this current has to be provided from this op-amp output somewhere. Now, as we know that typically this positive end is the positive supply, this is the negative end supply. So high current actually have to flow through this path, through this input, and eventually it has to come out through this way, and eventually this has to flow through this pathway. So the pulled current by the solenoid coil, which is a back EMF, because of the back EMF, will cause a very high current to flow through the op-amp circuit and the op-amp component itself, which can be devastating or destructive for the op-amp component because it is not designed to handle a very large amount of current. And this current is particularly not useful for us. This is something that we cannot deny. This happens because of two different things. One is called the inductance of a solenoid coil, and the second I forgot the second word. আরেকটা কি জন্য জিনিস আছে, so এই দুটো জিনিসের জন্য হয়. I'm not getting into the exact detail for why this is created. I'm just trying to tell you a similar thing by which you can make sense that coils
repeat করেন তো.
হ্যাঁ বলতেছি আমি, coils would appreciate to maintain their magnetic scenario or maintain the magnetic situation. So if they are magnetized, they will prefer to remain magnetized in that situation. If they are not magnetized, they'll try to repel becoming magnetized. So we do not want this high current to flow through the op-amp circuit. To avoid this flow through the op-amp circuit, we are introducing this pathway of wire over here. So this is where the wire is coming by. So the purpose of this wire with a diode purpose of for the timing concept, there is only a single piece of wire. The purpose of this wire is that whenever this thing will try to pull a huge amount of current, so it is now essentially having a large high voltage over here. It is having a very large current will flow from high voltage to low voltage, so in this manner. So this is the low voltage connection. So this coil is trying to produce a very back EMF, so it is trying to pull a very large current through here. We are providing this connection path over here so that this solenoid, as it is losing its current, as the current is slowly becoming zero, it can pull its necessary current from the ground connection, and we can have this high current flow through this pathway, and it can essentially die within this loop of the circuit. So this is the reason why we need this secondary pathway. Now you might wonder, well, fine, a single piece of wire should essentially suffice. What's the whole deal to give another diode over here? The diode is pretty important because the entire idea of this whole shebang was to make sure that this switch should work exclusively for the positive output, not for the negative output. So this is what we want to achieve. Now, if we do not provide this diode, if there was only a single piece of wire, and so you have to understand this thing. So current is starting to flow through here. It is flowing through the diode without obstruction. Whenever it reaches to this junction, it has two alternative pathways. It can either flow through a single piece of wire. Let's say if this diode did not exist, then this would be a single piece of wire, or it would have to flow through the solenoid. Essentially, the current would necessarily try to flow through the single piece of wire. So the current would not essentially go through the solenoid. We want the current to go through the solenoid and the back EMF to flow through this way. That's where this diode comes in. This diode would not allow the downward current to flow through this way. Rather, that's why the downward current will be made to flow through the solenoid coil, essentially energizing the solenoid and closing the switch and operating whatever the secondary circuit that we want to operate over here. And that this diode too, in that case, will prohibit or restrict the flow of current to become a short circuit. The moment we are reversing the output of the op-amp, so let's say positive becoming negative, then the current will start to reduce. This solenoid will produce a large high amount of back EMF. This diode too will allow this high current to flow within this loop for that short duration, and as a result it will stop any damage or prohibit any damage happening to the actual op-amp circuit, and also allow the current to flow through, so therefore there will be no damage. So the D2 is essentially required so that the main current, when the op-amp is actually doing its actual purpose, providing us a positive output, and this solenoid is actually energized, the D2 is responsible so that the current has to flow through the solenoid and does not get short circuited. We need this pathway to get rid of the problem of the back EMF. We need the D2 so that the main current flow has to go through the solenoid coil. It does not actually get bypassed through this alternate pathway. So এটা হচ্ছে এই সার্কিটটার purpose. I'll take questions from you, but let me finish one single thing. This is the circuit orientation, this is the diode orientation whenever this circuit is supposed to work for a positive and not supposed to work for a negative. If this thing is reversed, for example, if we want to have a circuit that we want to operate for a negative output and we want it not to operate for a positive output, then both of these diodes should have reversed, which means that in those cases this diode simply should become flip vertical like this, and this one should also become like this. So you have to read from the question and be careful that what kind of output do you want to operate it for. If you want it to operate for a negative supply, this is the diode directions. If you want it to operate for a positive supply, then this original figure is your diode direction. So that's the idea. I'll take questions, but before you start asking me questions, I would request all of you to read through this part, this small paragraph over here, and then you can ask any questions that I'd like to answer. এই প্যারাগ্রাফটা দেখো। ব্যাক ইএমএফটা কেন জেনারেট হয়, এটার ব্যাকগ্রাউন্ড কি এটা তোমাদের কোনো সময় জিজ্ঞেস করবে না, বাট I just give you a bit of an idea that why does the back EMF can happen, and it just says that according to your syllabus you just have to know that the back EMF could generates and it could damage the op-amp. Now what could that damage be? I also explained that so that you can easily remember this thing, but you don't essentially have to remember these stuffs to be able to write about them, as long as you can make sure you can mention that the output change of the op-amp would cause the back EMF generated in the solenoid, which could lead to a damage to the core main op-amp circuit. If you are able to mention this much, you are good to go. Questions, anyone?
Sir.
বলো।
স্যার আমি বলছিলাম যে মানে রিজনট গুলো কি ছিল জানি যে ব্যাক ইএমএফ জেনারেটেড হয়?
Because the coil does not want to accommodate the change of its EMF, change of its magnetic state. The solenoid wants to maintain its magnetic state.
স্যার এখন এখানে আরেকটা ব্যাপার কি থাকে যে বেসিক্যালি যেহেতু রেজিস্ট্যান্স কি বেশি না সার্কিটের তুলনায় সলিনয়েডটার?
কোন সার্কিট?
I mean the rest of the circuit.
Well, in this case, whenever the op-amp, for this circuit, this op-amp circuit, this part of the circuit is supposed to work for the positive output. Now, whenever the op-amp is essentially providing the positive output, for an ideal case, the diode doesn't have any resistance because it is in forward bias. So all the resistance is coming from the solenoid. For an ideal circuit, when the output is positive, the resistance is only from the solenoid. When it is providing negative voltage, if the output is negative voltage, then the diode will provide all the voltage, or will provide the infinite resistance.
Yes sir, তো যেখানে শুধুমাত্র সলিনয়েডের কেসটা আমরা কনসিডার করছি মানে পজিটিভ যখন আসছে তখন তো স্যার বেসিক্যালি ভোল্টেজটা মানে অনেক প্রপোর্শনালি অনেক হাই হয়ে যাবে না সলিনয়েডের ক্ষেত্রে জাস্ট বিকজ অফ দ্য হাই রেজিস্ট্যান্স? লাইক এটাও একটা ফ্যাক্টর হওয়ার কথা না?
Why would the voltage become magnified?
বিকজ স্যার এখানে রেজিস্ট্যান্স যে বেশি।
But that is the only resistance that you are applying, that is the output from the output. So you have a fixed amount of voltage, which is the terminal value of your supply voltage in the op amp, that is being available as a saturated output. That voltage is being applied across the solenoid coil. How do you get the magnification of the voltage?
আচ্ছা, আই এম আ বিট কনফিউজড উইথ দিস। মানে আমার কাছে মনে হয়েছিল যে মানে ব্যাক ইএমএফ এর ব্যাপারটা একটু লাগছিল আমার কাছে, লাইক কনফিউজিং লাগছিল আর কি।
আমি ব্যাক ইএমএফ এর জিনিসটা খুব সিম্পল দুটো সেন্টেন্সে বলতেছি। The solenoid is performing its magnetic task at a fixed voltage output from the op amp output when there is a fixed amount of current that is flowing through the solenoid. It will preferably try to maintain that magnetic state of that coil. It will not prefer to become demagnetized. Whenever the output of the op amp will become reversed from positive to negative, then the current flow will start to drop. In that dropping duration of the current, this will be very small, but for that, within that small duration of time, that coil will become demagnetized. The coil will prefer not to become demagnetized, and as a result, it will try to pull its own current from in which direction it is required to maintain that magnetism.
একটা হাই মানে এক্সট্রা হাই অ্যামাউন্ট অফ কারেন্ট সে অ্যাবজর্ব করার ট্রাই করতেছে অপ অ্যাম্প থেকে।
Exactly, for exclusively for the duration within which the current is dropping reserve. So the coil is trying to maintain that current. In other words, the coil is trying to maintain its magnetic state. It is not wanting to become demagnetized. So it was when it is not magnetized, it doesn't want to become magnetized. When it is magnetized, it doesn't want to become demagnetized. Pretty much it's a similar thing related to Lenz's law, but it's not exactly the identical scenario.
স্যার এরপরে যখন আমরা D2 অ্যাটাচ করে দিলাম স্যার, তখন তো একই লুপে আবার ফেরত আসতেছে না ঘুরে কারেন্টটা?
D2 টা connect করার পর the current is gonna flow through this pathway, but it will not be pulled from the op amp because the current can essentially very easily flow through this pathway. So this will
ও আচ্ছা,
fulfill the circuit.
মানে
And
একটা টাইম ডিউরেশনটা বেসিক্যালি মানে স্পেসটা বেড়ে গেছে আর কি কারেন্টটার ফ্লো মানে ইজ অফ
exactly,
ফ্লোর জন্য।
D2 path is basically working as a bypass path so that the current can be pulled from the ground, and the main op amp circuit, which is on the left side, right somewhere over here, this op amp circuit is not being affected.
আচ্ছা
ঠিক আছে? ইয়া ফাহিম কি যেন বলতেছিল?
আচ্ছা স্যার, আপনি যে বললেন যে যখন কারেন্টটা ড্র করবে তখন হচ্ছে ওই লুপটায় কারেন্টটা ঘুরবে, ঠিক আছে? এটা কি মানে কারেন্টটা যে ইনিশিয়ালি ড্র করছে ওটা কি অপ অ্যাম্প থেকে আসছে না?
ইনিশিয়ালি মানে হচ্ছে হ্যাঁ, ইনিশিয়ালি যখন আমরা এখানে যখন পজিটিভ আউটপুট ছিল ওই কারেন্টটা অপ অ্যাম্প থেকে আসছে।
আমি বলতে চাচ্ছি যখন হচ্ছে ডিম্যাগনেটাইজ হচ্ছিল তখন
হ্যাঁ
যে একটু পুল করলো তখন ওটা কি গ্রাউন্ড থেকে আসছে?
হ্যাঁ, ডিম্যাগনেটাইজ হওয়ার সময় তার সে যে এক্সট্রা কারেন্টটুকু পুল করবে, এক্সট্রা কারেন্টটুকু অ্যাকচুয়ালি হবে, টু বি অনেস্ট, in terms of value of the current, that can be very quite small, but the voltage that this coil will produce can be very large depending upon the number of the turns, which you don't have to know, but I'm just telling you because of the electromagnetic induction. ওই কারেন্টটুকু সে যে কোনো ভাবেই হোক উপর থেকে নিচে পুল করার চেষ্টা করবে। আর যদি এই প্যাথওয়ে না থাকে, if this pathway doesn't exist, then this coil will pull this current through the core op amp circuit. And if we have this bypass path, then this can very easily provide this pathway so that the op amp would not be affected.
তখন তাহলে গ্রাউন্ড থেকে কারেন্টটা এসে এখান দিয়ে যে ঘুরবে না?
হ্যাঁ, for that small duration, that high current will be flowing through this pathway, and the solenoid will have enough time to become demagnetized, and that way we can avoid the harm towards the main op amp circuit.
ওকে স্যার, থ্যাংক ইউ।
আচ্ছা, তোমাদের পরীক্ষা কি কি আসছে?
স্যার কালকে পরীক্ষা।
আগামী কালকে?
হ্যাঁ।
আচ্ছা, কি কি আছে সিলেবাসে?
এসি কারেন্ট, ফটো ইলেকট্রিক এফেক্ট, থার্মাল আর অসিলেশন।
আচ্ছা ঠিক আছে, I am actually well rested. If you guys want to have any specific problem that school করাইছে বা হচ্ছে, if you have some questions from the worksheet, I can make some time after the class is officially over, so I'll stop the recording, and if you kids want to stick by and show me some problems, you are welcome for that.
স্যার আমার কয়েকটা আছে
ঠিক আছে, সমস্যা নেই। ক্লাস শেষ হওয়ার পরে বলো যে স্যার I will show some problem, I'll stop the recording, dismiss the class so that anyone who wants to leave can leave, and then we'll pick it up. Yes, I'll continue the class from here. Abias, you have a question?
Yes, sir. To protect the op-amp from the back EMF, we use the D2 diode, right?
Not necessarily. The D2 diode is there. The purpose of the D2 diode is not to stop the damage. To stop the damage, a single wire would be enough. Purpose of the D2 diode is to stop the current that was originally coming from diode 1 not to bypass through a single piece of wire to the ground, so that that current would be pushed through the solenoid. D2 performs not when the back EMF is activated. D2 performs its blocking purpose when the solenoid is actually working, when the op-amp output is actually positive. The diode over here is required so that the current that is naturally flowing through this thing, when this external circuit is working, that current has to flow through the solenoid. It does not get bypassed through this path. But for the current to flow through this pathway, a single piece of wire would be good enough. But if we do provide a single piece of wire, then this current would be simply bypassed through here. It would not flow through the solenoid. So the D2 basically serves this purpose when the op-amp is providing its basic current.
Okay, I understand this part, sir, but how about D1? Doesn't it stop any current from the back EMF?
No, because the back EMF essentially pulls the current in the original direction that the current was flowing. So in this case, this was the high voltage output. Let me show you in this part. In this case, this was the high voltage output, and this is the ground. This is the zero voltage, which means basic current of this circuit was flowing downwards. So the back EMF will also try to maintain that current flow. So it will pull this current downwards. Now, if this pathway doesn't exist, it will pull this current through this main pathway. So D1 will not oppose that current flow because D1 is there to stop current flow upwards. It will very much allow the downward current flow.
Could you repeat that, sir?
D1 will not oppose the downward current flow. The solenoid will produce the back EMF to maintain the current that it was energized by. So the solenoid will pull a downward current. If this alternate path does not exist, then the solenoid will pull the high current downwards. In that case, this is the only path through which the current flow can happen. Then the D1 will allow all of that current flow because D1 will only restrict the current flow in the upward direction. Any amount of current flowing downwards, D1 can allow because it is forward bias for D1.
So how would the damage occur, sir? I didn't really understand.
The damage occurs because these components that we have over here, they are not designed to, usually not designed for a really large amount of current. For example, 1 or 2 ampere or this kind of current values. They are designed to operate at a certain voltage value, but for a very small amount of current. Like they are basically used for some signal decision making. So you cannot essentially have a pretty large amount of current that works through here. So if we do provide a very high amount of current, there is a possibility that these electronic component that is inside the op-amp circuit, which we did not discuss, but there is a series of transistors and diodes merged together, which actually basically does the job inside the inside the op-amp. That thing can become burned from the I square R effect of that back EMF current, which is significantly larger than the regular current value of the solenoid for that small duration of time.
So to divert this excess current, we're using a smaller loop.
Exactly.
Okay,
Sir,
And it is also very important that you please understand that this connection has to be connected after this diode. অনেক সময় স্টুডেন্টরা এই জিনিসটা ঠিক মতো আঁকে, বাট সামটাইমস দে কানেক্ট দিস থিং অ্যাবাভ দিস ডায়োড. দিস ইজ রং. এটা যাতে ভুল না হয়, এই পজিশনিং যাতে ভুল না হয়. This connection has to be here, right here. বলো.
স্যার আমি বলছিলাম যে আর্থ থেকে কারেন্ট পুল করার জিনিসটা সেন্স মেক করে নাই, মানে এটা কেন হবে? I mean, how will it happen actually?
Let's say, do you expect a current flow here?
Yes, sir.
Likewise. Only in this case, for this scenario, this solenoid will tend to behave like a temporary battery, which is going to look something like this. So the back EMF will pull a current in this direction. বুঝা গেছে?
Yes, sir.
Beautiful. So this is just one of the thing, and then they have introduced another circuit symbol, which is a diode. You know how the diode works, and what is shown over here, that this was the operation for the circuit whenever we wanted only one type of scenario to be achieved for one type of output of the op amp. So if positive output was available, then we would get one type of behavior for the external circuit, and then if we had negative output, we'd have another opposite type of behavior for the external circuit. In other scenarios, if you don't want a relay switch to be operated, rather you want some basic signaling, but you want two different type of signal for two different type of outputs, you can also have a circuit like this. This is a very basic circuit where we do not have any relay, but we just have two different diodes. They can be of different color, red or green or white, violet. You can choose any type of diode over here, but two different colors. And depending upon the output type, either of these diodes would be providing the current flow. The reason we have the resistors connected over here, which is pretty important, is for the safekeeping of the diodes. Because you should understand, ideally diodes are supposed to have zero resistance in forward bias, which means whenever this positive supply is, let's say in a certain scenario, this is the output of the op amp is positive, then in that case current flow will happen through this diode. Now, being an ideal diode, or LED is light emitting diode, but considering this, if you even consider this as an ideal diode, this will have zero resistance, which means it can essentially allow a very large amount of current. We don't want that to happen. So for the safety of this LED, we are introducing a small resistor over here, which will limit the current value, but the diode can still glow for whatever the current flow that happens through it. So if the output of the op amp is positive, in this case diode 1 will glow, diode 2 will not glow. If the output of the op amp is negative, then diode 1 will not glow, diode 2 will glow, because in that case this will be the high voltage 0 volt, and the op amp output will be negative voltage. So the current flow can happen through this pathway, and it can essentially does this work. And benefit of having these two diodes in opposite direction, that in this case no current flow can essentially be pulled from the ground, because what I need to understand, আসলে এটা একটু কপি করে নেই, এটা আঁকলে সুবিধা হবে। So whenever the op amp output is positive, in that case this will be this is 0 voltage, and this is the saturated positive voltage of the supply. Then current is flowing through this diode, and this LED is gonna glow, essentially glow. You cannot choose this LED to be a very highly powerful LED. For example, if it shouldn't be something of, let's say, 100-200 watt LED. It should be of some minimal power, because this LED will be altogether be glown by the current that will be drawn from the op amp. So whatever the current that this LED should be using, the op amp should be capable of providing and handling that current continuously. So they will not be very bright LEDs, or they will not be very high powerful LEDs, but they can essentially give you enough amount of signal that what is the possible output of this device. So they are good for close monitoring, or they can be placed on a single piece of dashboard where you have multiple different LEDs showing you that this is okay, this is not okay. For example, I mean, my point is that you shouldn't be seeing this LED's performance over a very large distance. So people have to observe or be alerted by these LEDs from a pretty close distance, because they shouldn't have too much power, because this current has to come from the op-amp. And whenever this is positive and this is the negative connection, current cannot essentially flow through this pathway, because in this case the current will not happen, because current will essentially try to go this way and this pathway will be blocked, so this will not be glowing. Vice versa, if the output of the op-amp is negative, in that case this will not glow and current will be flowing through this pathway, and then this diode 2 can essentially do the glowing and give you some signal. So এই কোশ্চেনগুলো actually খুব simple. এই কোশ্চেনগুলো to be honest অনেক rewarding এর জন্য বলতেছি that if you understand basically how this works, which is pretty simple in my opinion, you can just draw these circuits, and being able to draw two of these diodes in opposite directions scores you 2 marks. Labeling them properly scores you the second, being able to draw two of these diodes in opposite directions scores you 1 mark. Labeling these diodes properly as per the question says that draw for positive output, draw the red should glow, then you should label R over here, and the other one should be blue, then you should, proper labeling scores you the second mark, and being able to give the resistors in this connection scores you the 3rd mark. So just being able to complete this figure in many cases scores you a lot of marks for this kind of questions. And then this is a very interesting paragraph, which is the last part of our real sensing part. I'm going to read through this paragraph and help you to understand this thing. Have a look. Candidates should be able to show an understanding of the need for calibration where digital or analog meters are used as output devices. So why do we need the calibration? Have a look. An LED may be used to indicate whether an output is positive or negative. If the output from a comparator, if the output is from a comparator, then LEDs can give information as to, for example, whether a temperature is above or below a set value. However, the LED does not give a value of the temperature reading. This is important because the comparator circuit does not give a precise measurement of the temperature. It only compares the resistance values. Based upon that, it gives you either of the two saturation values, either the positive supply value or the negative supply value. So it does not give you the exact temperature, it only tells you whether the current temperature that you are sensing is above or below a set value that you have set from earlier. So it does not give you a precise temperature reading. It gives you a yes or no information. Is it above or is it below? That's it. Many sensors, for example, the thermistor and LDR, are non-linear. It was seen into figure 28G that the sensor could be connected into a potential divider circuit. So the output of the potential divider varied with some property, for example, temperature or light intensity. This variable voltage could be measured using an analog or digital voltmeter. So figure 28G, let's have a look at figure 28G. Where is 28G? 28G is a figure. In 28G. This is the 28G figure. So this is topic 28 and this is G heading. So what they're saying that in this case we can use a sensing device over here, and if we measure this output voltage by a digital or analog meter, we can, and if we calibrate this device with appropriate measurement, that physical variable, if you're using a thermistor, then the physical variable is temperature. If you use an LDR, the physical variable is the light intensity. If this voltage is calibrated for some known values, by observing the voltage, we could reciprocate back and have a absolute reading that what is the actual temperature of this device is. So that's what they're saying, that by measuring this thing properly, we can have this thing measured by a proper sensitive enough analog or digital device. And if that device is properly calibrated, it is possible for us to have an understanding that what is the exact value of the physical variable is exactly over at this place. So if we go back right here, Okay. This reading on the voltmeter would vary with the property being monitored. However, the reading on the voltmeter would not vary linearly with change in property. In order that the property can be measured, a calibration curve is required. The reading on the voltmeter is recorded for known values of the property X. A graph is then plotted showing the variation with the property X of the voltmeter reading. The value of the property X can then be read from the graph for any particular reading on the voltmeter. So this is a very basic idea of calibration, is that first we develop a set of, first we develop a curve, calibration curve, or in some cases it can be a calibration equation as well, which can have an exponential with appropriate powers and x-axis or y-axis intercept. You have to have access to either of these. Either you have to have an access of a curve, or you have to have access to an equation. And if you know an unknown value, I mean, if you plot, let's say, voltage versus temperature, then you have a curve. Then whatever the voltage that you get from a random reading, if you have that curve, you can extrapolate that information to get a certain temperature. So that's the basic idea for calibration, that if we can somehow, using some pre-known values, obtain the curve for how that voltage is varying with the change of the physical variable that we are measuring using the thermistor or the LDR in the potential divider circuit. If this thing is calibrated properly, then using that calibration curve, we can measure other unknown values as well. If you still find it a bit difficult, I can make it a bit more easier. For example, if you think about the process by which we actually have thermometers working for us, whenever we calibrate a thermometer, we don't essentially mark a thermometer for all the temperatures that we might measure with a thermometer. We keep the thermometer in melting ice. We mark it as 0 degrees Celsius. We keep the thermometer in boiling steam. We mark it at 100. Mark that as 100 degrees Celsius, and then we divide the entire space in between 100 equal spaces, where each of this division represent 1 degree Celsius. So that's basically calibration, that knowing what you are going to measure and then preparing the device to be able to measure other values. Now, one of the beauty of the thermometer is that the thermometric properties that we handle, they're all linear. All the thermometric properties that we use for a regular thermometer, especially for liquid in glass thermometer, alcohol or mercury that we use, their volume change happens linearly with the change of temperature. That's why we could divide it into 100 equal spaces, and each space can give us 1 degree Celsius. But that's not the case for resistance, or for that's not the case for an LDR resistance or the LDR or a thermistor resistance. It has a curved behavior. That's why we need to develop our device specific calibration curve, and if we have that curve, we can use that curve to measure unknown values as well. That's what this paragraph is about. That's pretty much it for the op-amp circuit. And before I jump into the remote sensing, which is actually the more detailed discussion, I'd like to show you 2 or 3 problems from the worksheet, so that it will be a bit more graspable for you kids, that what kind of questions are you going to face from here. I actually have prepared all of your worksheets over here. Here is booklet 2. All of the stuffs are over here. I just need to print them out. I would have started printing from last Friday, but I was really sick, so I couldn't. But I hope to be able to start from tonight. So এখানে এই যে সবকিছু দেওয়া আছে, যে অ্যাপ্লিকেশন বুটের পুরো নোট, রিমোট সেন্সিং তোমাদের সবকিছু গুছিয়ে রাখছি, জাস্ট প্রিন্ট দিলে তোমাদের বাইন্ডিং করে দিয়ে দিতে পারবো। So it's achievable and possible soon. এখান থেকে দেখাই, রিমোট সেন্সিং এর কোশ্চেন পেপার হচ্ছে এটা, মার্ক স্কিম হচ্ছে এটা। আচ্ছা, have a look. I'm just going to show you some very sample questions. I'm not going to solve the whole paper. We can try and solve this in time, but একটু বুঝার চেষ্টা করি আমি তোমাকে কি পড়ানো দেখা যাচ্ছে। Question, have a look at question number 1. State the 3 characteristics of an ideal op-amp. So here they're asking for state, so you don't need to give explanation. So you just write 3 properties. For example, we can write infinite input impedance, infinite open loop gain, 0 output impedance, infinite bandwidth, infinite slew rate. These are the 5 properties. You mention any of the 3 without spelling mistake, you scored these 3 marks. As simple as that. Now comes an amplifier circuit for a microphone is shown in figure 8.1. This is the circuit symbol for a microphone. Circle with the dot. This is the circuit symbol for a microphone. Name the type of feedback used in this op-amp. any type of feedback that you'll see is always negative feedback. So you just write negative. One word. If you don't do spelling mistake, you'll score this 1 mark. Now, just by looking at this circuit, what kind of op-amp circuit is this? Is this a comparator circuit? Is this an inverting amplifier, or is this a non-inverting amplifier? I'll help you to remember this. Can I bring this out? What did I just do? Beautiful. I opened it in a different tab. I did not know I could do that, but apparently I can, which is amazing. So I'm going to keep it over here and try to show you the 3 different type of op-amp circuits that we have come across to study so far. So let me just show you some samples. So this is one of the op-amp circuits that we've come across. Have a look over here. Do you see any similarities here? This is just one type. The second type is like this. This is the second type of circuit that you've come across to see, where you have the output and the input is entering into the inverting input. This is the inverting amplifier. Or the third type you can have, where you will always have saturated output, where you can have 2 different inputs coming from 2 different voltage values, and the output will be either the positive maximum or the negative maximum, depending upon what kind of voltage do we get over here, V plus and V minus comparison. Now, which circuit does this one look like? This one, or this one, or this one? Respond. Someone.
Non-inverting matter.
This is a non-inverting amplifier, yes. But do every one of you see that? If you don't see it yet, the easiest way to see it is that, have a look. In this case, the 2 inputs, one of the input is coming from the feedback loop, and the actual input from the microphone, because this is supposed to be the ground connection, they haven't labeled the ground over here, but this is usually always the ground. You can see that the actual microphone value is actually fed into the non-inverting input. So this is a non-inverting amplifier. And remember, the adjacent resistor is always the feedback resistance, and the other one is the other one. So in this case, this is the RF and X is the R1. So that's the basic circuit over here.
Sorry, inverting amplifier to basically same yeah, basically
the input is fed into the inverting input. That's the basic part. That's how you can differentiate very easily. The core input that will be providing to the op-amp will be connected to the inverting input, the minus input, V minus input of the op-amp. And in the non-inverting amplifier, the input will be connected to the non-inverting input. So this is the place where it is connected. So it will change circuit. So let's go ahead. I'd like to make this a bit wider, so it's visible for everyone. Okay. So the output of the potential difference is V out is 5.8 volt for a potential difference across the resistor of R of 69 millivolt. The gain of the amplifier circuit. আচ্ছা ঠিক আছে, আমি এটা পুরোটা কপি করতে পারবো কি এখান থেকে? I think পুরোটা পাওয়া যাবে না একবারে. So let's copy multiple pieces. This is the circuit that we have. That's a bit big. আচ্ছা সমস্যা নাই.
Sorry, you could just snip and sketch.
I could. Okay, let's say this is the whole portion that we have. So let's have a look. First of all, this is a circuit that we have. The output potential V out is 5.8 volt for a potential difference across the resistor R of 69 millivolt. So bujo question ki bolse. The question is telling us that for this circuit, the output is equals to 5.8 volt for a potential difference across the resistor of R 69 millivolt. So in this case, this V plus, or in other case, what we call the V in this case, this is the V in. V in equals to 69 into 10 to the power minus 3. volt. So in this case, first of all, they're asking us what is the gain of the amplifier circuit. The gain is always given by what? Gain equals to
large minus
V out by V in. Exactly. So that is 5.8 divided by 69 into 10 to the power minus 3. So whatever the value you get, you write that part in standard form. Then they are asking us what is the value of the resistance X. Resistance X is bottom one. So this, because this is a non-inverting amplifier, we should remember the equation for the non-inverting amplifier. Non-inverting amplifier gain equation gain equals to 1 plus RF by Rx. In this case, I'm writing as X because they have labeled this resistor as X. So I'm gonna play, this is the gain value that I have calculated over here. I'm gonna place this over here. 1 comes as 1. RF value question e dawa ase. Dekho fibrin resistance value koto? 120 kilo. So you just place this over here. Ultimate answer okay kilo ohm jaise na sorry ohm jaise. So I might as well place 120 to 10 to the power 3. And you then just calculate the Rx value because you know this value. Here is the whole thing. Do the side changes and calculate this value, and eventually you get 2 marks out of it.
So 1 plus RF by Rx to formula.
This is a very basic formula.
Sir, এটা কি ইনভার্টিং নন ইনভার্টিং দুইটার ক্ষেত্রে হবে নাকি?
না, এটা শুধুমাত্র নন ইনভার্টিং এর জন্য। ইনভার্টিং এর ফর্মুলা হচ্ছে এটা।
আচ্ছা আচ্ছা।
minus RF by Rin. They have different formula. State one effect of the amplifier output of reducing the resistance of resistor X. আচ্ছা, এই জিনিসটা একটু খেয়াল করি। State one effect on the amplifier output. One effect on the amplifier output of reducing the resistance of resistor X. So এই ইকুয়েশন দেখো, এই ইকুয়েশনে যদি আমি এটার ভ্যালু কমাই দিই, এই ডিনোমিনেটরটা কমাই দিই,
গেইন বাড়বে,
টোটাল জিনিসটার গেইন বাড়বে। এক্স্যাক্টলি। ইফ দ্য ডিনোমিনেটর বিকাম স্মল, তাহলে এই ফ্র্যাকশনটার ভ্যালু বেশি হবে। এই ফ্র্যাকশনটা যত বড় হবে, আমার গেইনটা বড় হবে। গেইনটা বড় হলে আমাদের আউটপুটটা কি হবে? আরো বড় হবে। সো এখানে একটা জিনিস হচ্ছে স্টেট দ্য ইফেক্ট অন দ্য অ্যাম্পলিফায়ার আউটপুট of reducing the resistance of resistor X. I could have only write the output increases. They have only asked for state, not explain. So you can write output increases. That should be enough. But I'm going to look at the mark scheme as well. Now, output increase hole eventually একটা effect হতে পারে যে it could become saturated. But whether it is going to become saturated or not, that we cannot essentially say because this circuit does not tell us what is the supply value of this op-amp. You can see in this circuit that just to avoid complicity, they haven't shown us the supply voltages, supply lines, because they can be in many cases omitted. So let's have a look at the mark scheme. What do they say? Sorry, I mean remote sensing and mark scheme on kore felchi. Remote sensing আমাদের লাগবে হচ্ছে direct sensing and mark scheme. Gain increases or output increases, or they are saying bandwidth reduced. আচ্ছা, bandwidth reduced এই পার্টটা এটা অ্যাকচুয়ালি কোত্থেকে আসে সেটা আমি তোমাদের বলতে পারবো, বাট এটা কেন হয় সেটা রিজনই আমি তোমাদের বলতেছি না, বিকজ আই অনেস্টলি ডোন্ট নো। এটা সোর্সটা হচ্ছে এখানে, ইফ ইউ হ্যাভ আ লুক ওভার হিয়ার, দ্য বেনিফিট অফ নেগেটিভ ফিডব্যাক হচ্ছে তিনটা: an increase of bandwidth, less distortion, greater operating stability, which means the more you have the effect of negative feedback, which means the smaller your gain is, because the whole point of applying negative feedback to the circuit of an op-amp circuit is to reduce the gain. The smaller the gain, the more or the better is the negative feedback. So whenever our gain is becoming larger, it means we are going to slowly not getting as much as benefit that we could have from here. So they have mentioned over here that whatever the bandwidth that we had over here, we're going to have that reduced. So whenever the gain is becoming increased, which means that the negative feedback is becoming smaller, bandwidth will become decreased. You can write this and it is equally mark scoring, but I personally don't find this very easy to remember, or I also find this a bit far-fetched because these things are much too simpler to remember and work by. The examiners report says the majority of candidates made reference to output increases. Only a minority considered either the gain or the bandwidth of the amplifier. So this is basically not an error. They are just saying that what kind of differences did they see. All three of them are equally correct answer, equally mark scoring. So that's that.
স্যার ব্যান্ডউইথের ব্যাপারটা এখানে আমি একটু কনফিউজড আর কি, মানে বেসিক্যালি অপ অ্যাম্পে ব্যান্ডউইথটা কিভাবে কাজ করে?
Bandwidth is about how fast the op-amp can, to what range of frequency of the input alternating signal can the op-amp handle properly. So if an op-amp has a high bandwidth, it means that it can handle a high frequency input AC signal, and vice versa.
স্যার বুঝলাম না, মানে হচ্ছে
physical একটা example যদি দিই, physical example হচ্ছে এরকম, let's say we have an op-amp circuit like this. Let's say on this LDR we're gonna set up some flickering light. Let's say that light source is gonna flicker, let's say 1000 pulses per second. So you're basically gonna trying to change the output from positive to negative 1000 times every second, but all of these outputs are supposed to be saturated, so this is gonna be plus minus Vs of this output, but you're gonna have saturated yet changing output. So this op-amp, if it can cope with 1000 hertz, will be giving you 1000 hertz of output. So it can handle 1000 hertz. That's a value of its bandwidth. If this op-amp is designed to operate at a maximum frequency of, let's say, 10,000 hertz, which means that if the input signal changes 10,000 pulses per second, this op-amp would be able to handle that information. It will still be able to give out that similar frequency of output. But whenever the input signal frequency goes above that range, then this op-amp wouldn't be able to give you that exact frequency. So it will be lagging behind. So increased bandwidth means that whenever we apply negative feedback to a circuit, its useful frequency range gets bigger. Without the negative feedback, সে যতটুকু high frequency handle করতে পারতো, with negative feedback, it can handle a much higher high frequency for input signal.
আচ্ছা স্যার, বুঝতে পারছি।
I'm telling you what it means. I'm not telling you how does the op-amp does that, because I don't know that, and it's not in your syllabus either.
So sir, by handling you mean the input frequency ta output frequency ta same থাকবে?
Yes. Okay, so let's have a look at another of these questions. This is just a very basic block diagram. You know this thing: sensor device, processing device, output device. Fill up these two blocks, you get 2 marks. I mean, this is just whatever. Okay, yeah, have a look. Here it says a device is to be built that will emit a red light when its input is plus 2 volt. When the input is at minus 2 volt, the light emitted is to be green. On figure 9.2, draw a circuit diagram of the device. So basically in this case, you simply have to provide this figure, eta. So এখানে বলছে হচ্ছে plus 2 এর জন্য আউটপুট হতে হবে red, minus 2 এর জন্য আউটপুট হতে হবে green. So you just simply gonna draw 2 LED circuits over here. যেটা তোমার ডাউনওয়ার্ড এলইডি থাকবে সেটাকে লেবেল করতে হবে রেড, যেটা আপওয়ার্ড থাকবে সেটাকে লেবেল করতে হবে গ্রিন। এখানে 2 মার্ক দিচ্ছে, সো তোমার রেজিস্টার আঁকা লাগবে। এই 2 মার্কের ডিস্ট্রিবিউশনটা আমরা একটু দেখি। এটা হচ্ছে কোশ্চেন নাম্বার 2 এর বি। 2 LEDs with opposite polarities. So just দুইটা এলইডি অপোজিট পোলারিটিতে দিলেই 1 মার্ক। This is to understand that they have to work differently. Currently identified as red as green, এটার জন্য হচ্ছে 1 মার্ক। সো একটা রেড একটা গ্রিন যদি কারেক্টলি আইডেন্টিফাই করে তাহলে হচ্ছে 1 মার্ক। এখানে 3 মার্ক নাই বলে রেজিস্টারের মার্কটা দেওয়া হয় নাই। But if this question, in some of the later questions, you see that this exact question has 3 marks in it. In those cases, the 3rd mark comes for the addition of the register. We might as well look over here. Some attempted to give a use for the circuit example traffic lights rather than explain this action. Sorry, B1, my bad. Many candidates attempted to include an op-amp in the circuit. This was completed successfully by many, but was not necessary. Beautiful, exactly. It was surprising to note that large proportion of candidates who were unaware of the electrical symbol for an LED. Okay.
The question diagram to দেখান তো।
So I'm bold to say this last line of the examiner's report, this one would mean that many students actually, I believe they did draw a very basic bulb like circle and cross at the center, other than showing an actual LED with a directional light. So actually ওটা দিলেও সমস্যা ছিল না, আমি যদি তিনটা জিনিসকে আলাদা আলাদা দেখাই। For example, if I show a circuit like this would not be wrong by in all sincerity. For example, let's say This is your plus minus 2 volt supply, and this is your ground. So other than showing an LED, because the question didn't specify যে আমাদেরকে LED আঁকতে হবে, question কিন্তু LED কথা specifically বলা নাই। question কি বলছে? A device will emit a red light and it will emit a green light. So if we draw a circuit that looks something like this, I'm gonna give the resistor first because I would like to give this, and then I draw a downward basic diode, and then draw a bulb and label this red, and do the exact opposite thing. I draw a basic resistor. আচ্ছা, যদি আমি এখানে এরকম করে কি তাহলে রেজিস্টার অ্যাকচুয়ালি না দিলেও সমস্যা নাই, because the bulb should actually provide enough resistance so that the diode doesn't get burned out. But this would essentially work. So you can give another diode over here, because these are shown as normal diodes, not LEDs, because I am not using arrows over here. They are just basic diodes used for connection. And you can, if you just write this green, this would also do the purpose, because you are essentially controlling the current flow by providing the diodes. But this is essentially, in my opinion, this is actually redundant, because you can make them LEDs by just giving 2 arrows. So why bother showing the thing? But once again, if you want to show it this way, you would still score full marks. But in this case, showing these 2 resistors would not be necessary, because the bulbs can provide enough resistance that you need to limit the current value. হ্যাঁ, আবিয়াস বলো। কোশ্চেনটা এখানে আছে। শুভ্র দেখো, আবিয়াস বলো, you raised your hand? Yes.
Sir, I want a quick question about Earth. Is it like an infinite, can I assume it to be an infinite reservoir of electrons always at 0 volt?
Here?
The Earth wire.
The earth connection?
Yes, sir.
Yeah, technically yes. The earth connection is considered to be an infinite source of 0 volt electrons. Yes. That's the theoretical definition, but for practical purposes, the way we decide that an earth connection can be a large enough metallic body that have so many free electrons that that big number can be considered to be infinite for our requirement. For example, for the case of a car body, for the requirement for a car's electrical circuit, the entire metal chassis is considered to be the earth. The entire metal chassis is considered to be earth. Which is possible to achieve for metal bodies. For example, if you have aluminum body, or if you have basic iron made chassis. But for cases where you have carbon fiber made bodies, then you have to have artificial earthing circuit, or you need to have your entire electrical circuit working exclusively through your battery. You are not going to have a basic earthing. But earthing essentially mean that we have such a huge reservoir of electrons that a small bit of addition or subtraction would not change its voltage effectively. Yes.
Another thing, sir, what does saturation mean?
Saturation means the output of the op-amp becoming equal to the highest value of the supply voltage.
Output of the op-amp
becoming equal to the highest value of the supply voltage, either the highest positive supply voltage or highest negative supply voltage.
Okay, sir. Thank you.
হ্যাঁ, শুভ্র বলো।
স্যার এখানে তো বেসিক্যালি যখন +2 ভোল্ট হচ্ছে ইনপুট, তখন হচ্ছে ডায়োডটা ডাউনওয়ার্ডস পয়েন্ট করা থাকছে, তাই না? বিকজ হায়ার পটেনশিয়াল থেকে লোয়ার পটেনশিয়ালে যাচ্ছে।
Yes.
আর ইটস দ্য ভাইস ভার্সা আর কি,
For the green, yes.
-2 ভোল্ট। আচ্ছা, নেগেটিভ ফিডব্যাকের ব্যাপারটা একটু আরেকবার এক্সপ্লেইন করেন তো।
না
লাইক
না Let's look at other questions. Explain briefly the action of this as device. I'd like to leave this question in your hands. আচ্ছা, এখানে বলছে by reference to an amplifier, explain what is meant by negative feedback. This is basically the definition of negative feedback. Should be your question popped up, so might as well look over here. Negative feedback এর basic meaning টা হচ্ছে attaching or adding a small fraction of the output of an op-amp to the inverting input of the op-amp, so that the Vin would become smaller and the gain would become smaller.
বাট স্যার এটা
So,
তো নন ইনভার্টিং
এই
এর
দেখো,
ক্ষেত্রে হয় না।
no, the idea of negative feedback is that the feedback would be always attached with the inverting input. That's the whole point of negative feedback, যেটা আমাদের যে এই ফিগারটাতে খুব ভালো মতন দেখানো আছে, right here. এই যে a fraction of output is connected to the inverting input exclusively. So if the input is connected to the inverting input, you just basically add it through a wire. If the input is to be connected to the non-inverting input, the feedback fraction itself becomes the V minus. But feedback fraction is always connected or itself allowed in the V minus. Feedback
Sir.
fraction is never allowed in the V plus.
বেসিক্যালি যে স্যার যেটাকে ফিডব্যাক হিসেবে নিচ্ছি ওটাই কি ভি ইন হয়ে যাচ্ছে তাহলে?
এই আবার বলো,
লাইক আমরা কি বেসিক্যালি ভি ইন এর সঙ্গে অ্যাড করতেছি ফিডব্যাকটাকে, নাকি হচ্ছে জাস্ট মানে
আমরা V minus এর সাথে অ্যাড করতেছি।
আচ্ছা, সো ভি ইন ইজ অ্যাকচুয়ালি চেঞ্জিং ফর দ্যাট।
V in is actually becoming smaller because V in is becoming V plus minus V minus. So V minus যদি একটু করে বড় হয়ে যায় তাহলে ডিফারেন্সটা কমে আসবে।
বুঝতে পারছি স্যার।
সো এটার ফিজিক্যাল ওয়ার্ডিংটা আমরা একটু
স্যার
দেখি।
ওখানে একটা পয়েন্ট ছিল যে এন্ড ইজ আউট অফ ফেজ, এটা মানে এটা
বলতেছি, এটা বোঝানোর জন্য এখানে আসলাম। এখানে বলছে part of the output is added or to or slash return to mix with the input. So this is the basic idea of addition of feedback, and is out of phase with the input or fade to inverting input. Out of phase of the input মানে হচ্ছে, লিখে দেখাই, একটা জিনিস খেয়াল করো, if you think that our output is supposed to be gain into V plus minus V minus. Now, if V plus is bigger than V minus, then this will lead V out to be positive. A feedback, etar ekta certain part, let's say we're gonna take, let's say, alpha fraction. So let's say alpha percentage. I'm just writing this as a basic variable alpha. It doesn't have to be, it could be anything. We're gonna add a positive fraction of output voltage and we're gonna add it to the V minus, whereas the symbol before the V minus is actually negative, which means this positive fraction of the output voltage is attached with the V minus input. So it's connected to the inverting input, or it is out of phase. So for a positive voltage, you are providing a negative feedback because you're connecting it with the V minus. That's one way to go for. Alternately, if for the circuit, originally V plus is less than V minus, in that case V minus is the big one, positive or negative doesn't matter, but by number, as number, V plus is less than V minus, this would lead output to be negative. Now if V plus is less than V minus, now try to think about it, আমাদের V in টা কি হবে? V plus minus V minus, which means if you think for the whole V in value, basically the V in itself will be what? Negative হওয়ার কথা না?
স্যার ম্যাগনিটিউডটা কনসিডার করলে
Exactly. If you just do basic subtraction, the input is supposed to be negative, but we're gonna take a small fraction out of this V out. Let's say we're gonna take alpha percentage of this V out, which is the feedback fraction, and we're gonna connect it with the V minus. Now this V minus essentially has a minus sign in front of it, which means what? We're gonna take a fraction of negative output voltage and attach it with the V minus, which will ultimately make the mathematical operation positive, because we are going to add that fraction, because V minus in this case is the bigger value compared to the V plus. So because the output is itself negative and we're gonna add this with the V minus, so practically speaking, we're gonna make the V in bigger, or we're gonna add a certain part with the V plus. By both of these mechanisms, what we are essentially trying to do, we are trying to bring the V in far closer towards zero. We are making the V in smaller. Either easily magnitude আমরা কমা ফেলার চেষ্টা করতেছি. That's the end expectation. So this is why they have used this word. This is actually very important, that is out of phase with the input. Is out of phase with the input means if your input itself is positive, then the feedback fraction would try to subtract value out of it so that it becomes much closer to zero. If the input itself is negative, then the feedback fraction would be something positive so that it would bring itself even closer to zero. So your feedback fraction will be always of opposite polarity compared to your input voltage. বুঝা যাচ্ছে?
জি স্যার।
জি স্যার।
Good.
Sir, V plus minus V minus, so why is it negative?
কোথায়? কোনটাতে? কোন জায়গায়?
So yeah, second part of V minus is greater than V plus. And the V plus minus is a negative. The positive.
Also, because I consider over here this, I mean, this is one scenario where I consider the V plus is bigger than V minus. In that case, we are going to have one output to be positive, which if added to the V minus becoming means that we are doing the opposite polarity addition. Vice versa scenario, এটা এক টাইপের সিচুয়েশন, অথবা অন্য যে সিচুয়েশন হতে পারে V প্লাসটা আমাদের ছোট হতে পারে V মাইনাসের থেকে. So this is another type of scenario that is dependent from the input side, and exactly input কি হবে সেটা তো আমরা কন্ট্রোল করব না, because input is basically the independent variable. We are controlling the behavior of the input. We're not essentially controlling the input which is fed from the physical device, but by implying or implementing the negative feedback loop, we are controlling the size of the input so that the saturation can be avoided. So this is just another possibility for the input size. বুঝছো?
So we're basically trying to make V plus and V minus almost the same via a negative feedback mechanism.
Beautiful. That's precisely what we're trying to do. Or in other words, we are trying to V in as close as possible to zero. That's the whole aim of negative feedback, so that the output can be avoided to be saturated, so that we can avoid the saturation of the output.
Yes, sir.
So yeah, if we have a look over here, many can paraphrase the question. Paraphrase the question means they just wrote the same answer as a question in different set of words, using the term feedback. Okay. It was common to find that there was no direct reference to the inverting input. Terms such as negative pin were quite usual. So negative pin is actually, no, there is no such thing as negative pin. These are just two different type of inputs, and some person who first denoted this parts symbol decided to denote them as plus and minus. There is no such thing as negative pin or positive pin. No. Inverting input and non-inverting input. No such thing as negative input or positive input. No. Negative supply and positive supply, that's okay. But plus and minus of the op-amp, they don't mean negative input or positive. They mean inverting input and non-inverting input. So don't mess up the names. It's very important that you don't mess up the names. It's pretty common.
এখানে তো আমরা যে we don't do the, মানে আমরা যখন সাবট্রাক্ট করছি like V plus minus V minus, তখন তো আমরা এই যে সাইনটা কনসিডার করি না, রাইট? জাস্ট ম্যাগনিটিউডটা সাবট্রাক্ট করে দিচ্ছি না?
আবার বলো।
স্যার এই যে যখন আমরা ইনভার্টিং মানে নন ইনভার্টিং মাইনাস ইনভার্টিং ইনপুটটা সাবট্রাক্ট করছি, তখন এখানে কি আমরা নন ইনভার্টিং এর আগে যে নেগেটিভ সাইনটা আছে ওটা তো আমরা নিচ্ছি না, রাইট?
No, we are. This subtraction is mathematical subtraction. This is not modular. This is bracket. Always bracket.
Right, huh?
This is mathematical subtraction, not difference. No. This is essentially why V in itself can be positive or negative. If V plus is bigger than V minus, it means V in is positive. ঠিক আছে, or vice versa. আচ্ছা আমরা আরেকটা কোশ্চেন দেখি, আর এক দুটা বা কোশ্চেন দেখি টু কমপ্লিট এটা কিছু কোশ্চেন পাই ভালো। এটা একটা নন ইনভার্টিং অ্যাম্পলিফায়ার, ইউ ক্যান সি ইট ফ্রম হিয়ার। আচ্ছা, have a look over in this circuit. The circuit diagram for figure 9.1 is an amplifier circuit incorporating an operation amplifier op amp. So we have this circuit over here, and just by looking at this circuit you should understand this is a inverting amplifier. You can see that the ground is fed to the positive and the feedback fraction is connected to the V minus, and the input is also connected to the V minus, and you can see over here that the supply voltage is inverted, where the output is plus minus over here, so they're in opposite polarity. So this is a basic property. I mean, in a lot of different characteristic consideration, we can say we should be able to detect that this is a inverting amplifier circuit. So on figure 9.1, mark with the letter X the virtual earth. So you have to place X over here. What is meant by virtual earth? So you have to give that idea of approximation. Then it says in bright sunlight, blah 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 blah. Acha, এই জিনিসটা বলি, in bright sunlight the LDR, the light dependent resistor has a resistance of 200 ohm. Calculate for the LDR in bright sunlight the voltmeter reading. So আচ্ছা, এখানে একটা জিনিস খেয়াল করো, in bright sunlight the light dependent resistor LDR has a resistance of 200 ohm. So in this case this one would have a resistance of 200 ohm, whereas we have connected a fixed resistor of 1 kilo ohm right over here. So you have to understand that for this circuit this 4.2 kilo ohm is the feedback resistance, which is the fraction of voltage which is fed back to the V minus side. So এটা হচ্ছে আমাদের feedback fraction. This is the RF, and everything that is over here that is connected from V in will work as our R in. If I just have a look, to help you to remember, have a look. This is the core circuit. This is the feedback resistance, and the other part before on the left of the virtual earth point from the V in, this thing is the R in. In this case, it means that the series combination of this one plus this one is working as R in. এখানে যদি এই LDR-টা যদি এখানে প্যারালালে দেওয়া থাকতো তাহলে এই প্যারালাল কম্বিনেশনটা হয়তো হচ্ছে R in. So depending upon what is given over here, ওটার উপর বেস করে আমাদের এই কোশ্চেনটা বানাইতে হবে। So আমি এই কোশ্চেন একটু সলভ করার ট্রাই করি, just to show you a bit of an example for how to solve this or approach these questions. Might as well delete everything. Paste. This is the question. Control Z. V. Okay. Question কোথায় গেল? এই যে আচ্ছা, এইটুকুই থাক। সো এখানে আমাদের যেটা বোঝা লাগবে সেটা হচ্ছে এটা 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 আচ্ছা, এখানে আমাদের ইনপুট ভোল্টেজ দেওয়া আছে হচ্ছে 1.5। আচ্ছা, এটা বের করার জন্য ফার্স্ট আগে আমাদেরকে গেইন বাই করতে হবে। সো আমাদের গেইন ইকুয়ালস টু হচ্ছে মাইনাস RF বাই R in। এখানে RF হচ্ছে 4.2 into 10 to the power 3 divided by R in হচ্ছে 220 plus 1000। এখান থেকে একটা ফ্র্যাকশন আসবে, দেখো তো এটা কত আসে।
Sir, 220 and 200.
Oh, sorry. Thank you, sorry. 1200 3 12 36 36 আর 6
And 5.
হ্যাঁ
3.5.
minus 5
minus 3.5.
3.5। সো এটা হলো গেইন। এরপর হচ্ছে সিম্পলি আমাদের এখন আউটপুট বের করতে হবে। সো আমাদের এখানে আউটপুট হবে হচ্ছে minus 3.5 into minus 1.5. I have a reason to write minus 1.5 because I can see that this supply is connected the other way around. So actually আমার এই পয়েন্টের ভোল্টেজটা কিন্তু হচ্ছে minus 1.5 volt. Have a look. because the positive end is connected to the ground, which means the positive end is working as 0 volt. So the actual input of this circuit is actually minus 1.5 volts. So by observing this connection type, I'm writing minus 1.5 volt over here. So this would
এই ব্যাপারটা মানে বেসিক্যালি ভি ইন ইনটু গেইন করতেছি, রাইট?
yes, but because this is an inverting amplifier, I have to bring in the minus sign. 5.25 plus, so I'm gonna read plus 5.25 volt to the OS. I'll check my working. I hope it's correct. Yes. Total input increase, input resistance 1.2 kilo ohm, amplifier gain minus, ultimately এখানে minus থাকতে হবে, voltmeter reading minus 3.5 into minus 1.5 equals to 5.25. Total disregard of signs or incorrect sign in answer maximum 2 mark. মানে হচ্ছে কেউ যদি সাইনের পুরো জিনিসটা হিসাবই না করে, বা এখানে মাইনাস দেয় নাই, বা এখানে মাইনাস দেয় নাই, বা এখানে মাইনাস দিচ্ছে এখানে মাইনাস দেয় নাই, আলটিমেটলি এটা মাইনাস আসছে, মানে মাইনাসের পজিশনগুলা ভুল করছে, অথবা মাইনাস গোনার ভিতরে ইউজ করে, মানে অল টুগেদার ম্যাথে ইউজই করে নাই, সেক্ষেত্রে এই টোটাল 3 মার্কের মধ্যে ম্যাক্সিমাম 2 পাবে। So yeah, it's important that you consider this minus. এখানে যদি ওরা although they did not actually give the plus sign over here, but I highly appreciate that you, for the case of voltage calculations, you always give the plus sign in appropriate places. Pretty important, in my opinion. It's actually quite important.
স্যার আরএফ তো সবসময় হচ্ছে বেসিক্যালি আমাদের ইনভার্টিং ইনপুটের সঙ্গে যেটা কানেক্টেড, রাইট?
Yes. Yes. Yes.
আমাদের আরএক্স যেটা, সেটা হচ্ছে সবসময় মানে অপ অ্যাম্পের ইনপুটের সঙ্গে যেটা কানেক্টেড,
ইনভার্টিং ইনপুটের সাথে যেটা কানেক্টেড। হোল আপ আরএক্স বলতে তুমি কোনটা, আমি কি মিন করতেছো?
মানে স্যার ডিনোমিনেটরে যেটা রাখতেছি।
ডিনোমিনেটরে যেটা আসতেছে সেটা হচ্ছে নিউমারেটরে ছাড়া যেটা, সেটা। আর নিউমারেটরে থাকবে হচ্ছে আউটপুটের সাথে অ্যাডজেসেন্ট যে সার্কিট রেজিস্টার থাকবে সেটা। দ্যাটস হাউ আই প্রেফার টু গো বাই।
ও হ্যাঁ, বুঝতে পারছি।
মানে এক্সক্লুসিভলি ডিনোমিনেটরটা ডিটেক্ট করতে গেলে যেটা হয়, তোমার পুরো সার্কিটের পুরো স্ট্রাকচার মনে রাখতে হয়। দ্য প্রসেস অফ, মানে কি বলো, মানে সাবট্রাকশন বা মানে প্রসেস অফ এলিমিনেশন অ্যাকচুয়ালি ওয়ার্কস বেটার। আচ্ছা, এখানে আমাদের একটা সার্কিট ভ্যারিয়েশন দেওয়া আছে, এখান থেকে কিছু ভ্যালু বাই করতে হবে, এটা তো কঠিন কিছু না। এখানে আচ্ছা, এটা হচ্ছে একটা weird circuit. Have a look over here that in this circuit they actually have both type of inputs apparently. So they have a feedback resistance over here on the positive side, they have feedback resistance over here. So if you are asked to detect the type of circuit that this is, you're gonna be in a lot of trouble. And to save you this trouble, you are not even asked to mention the type of circuit that is. They have already given you the equation for how this circuit will operate. So a circuit, for this circuit you don't have to know / remember / learn the exact equation by which this circuit will operate. They have, if they are deviating from the basic 3 type of circuit that you are supposed to know, comparator circuit or inverting amplifier or non-inverting amplifier, if they deviate from those circuits in any manner, they will always give you the operating equation of the circuit so that you can do your necessary calculations. So that's what they have given over here, and you just write up all these values and eventually slowly go ahead and do the calculation and blah 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 blah. You don't have to bother anything about that. But circuits which are not similar to what you've learned can show up. That's my point. And don't be hassled or don't feel bothered about this. If they do show up, you're gonna have the necessary clues for which using which you should be able to solve it pretty easily. And then we have some other questions. Acha, this is actually a pretty nice question in my opinion. We might as well try to solve this one. এখানে আমাদের idle up and we have to idle up and ওকে, ঝামেলা নাই। এই কোশ্চেনটা আমরা একটু দেখি। It's a good one. Might as well zoom it whole. পুরোটা জুম করলে কি দেখা যাবে? দেখা তো যাবে না। বল, তোমরা কি পড়তে পারতেছো? এই ফন্ট সাইজ দেখাও তো। Can you read this?
Yes, sir.
Or I could actually try one thing. And this might be a bit more better visible. আচ্ছা, হ্যাঁ ঠিক আছে। এটারে হাত দিয়ে ধরে মুভ করানো যায়? আচ্ছা, নেভার মাইন্ড। সো কোশ্চেনটা আমি আগে বলছি। কোশ্চেনটা হচ্ছে, we have a circuit given which is like this. Actually, what's the difference? The same thing. Anyway, এখান থেকে দেখো, the circuit figure 8.2 is used to monitor the input voltage Vin. So we're gonna provide this Vin in different parts. Take a good look. This Vin would be a certain input voltage coming from some source. Source এখানে দেখানো নাই, but you have to see that this Vin can be fed to the non-inverting input for these two op-amps. So whatever the voltage will be fed over here, the same voltage will be fed over here as well at the same time. However, the inverting input of these two op-amps are coming from these two junction points A and B, which are coming from a much bigger voltage value plus V. এই প্লাস ভি এর ভ্যালুটা আমাদের কত সেটা মনে হয় দেওয়া নাই, টু বি অনেস্ট সেটা আমাদের লাগবেও না, because we have the exact value of the A point and B point mentioned over here. So we just have to fill up this table, tick and cross, and we have 3 marks for this tick and cross. So let's go through. Question was at point A, a potential of 5 volt is maintained. At point B, a potential of 3 volt is maintained. Complete figure 8.3 by indicating with the tick the light emitting diodes LEDs that are conducting for the input voltages being shown. Also mark with the cross those LEDs that are not conducting. So you can see in this case both of the LEDs are aimed downwards, which means these LEDs are gonna only glow only if the output is positive. Output positive হলে শুধুমাত্র এলইডি গুলো গ্লো করবে, আউটপুট নেগেটিভ হলে এলইডি গুলো গ্লো করবে না। আউটপুট পজিটিভ হওয়ার জন্য আমাদের কি দরকার? এটা দরকার, ঠিক না? এটা কি বুঝতেছো সবাই?
Yes, sir.
আউটপুট পজিটিভ হতে হলে এটা হতে হবে, V plus should be bigger than V minus, so that the suppression result is positive, your output is always positive. So although we have to judge that whether this is available or not. So let's go for the red LED for this one. Whenever the Vin is plus 2 volt, in that case V minus is 3, V2 is 2, red LED will not glow.
Cross.
Green LED, this is 2, this is 5, this will not glow either. So now it should become, it হচ্ছে একটা ওয়ে to solve করা. The alternative way that you can go by is that you can see over here that for the green LED, this one, the V minus is maintained at plus 5, which means this one will only glow, green LED will only glow when its V plus is bigger than 5.0 volt, plus 5.0 volt that is. If this is true, only then the green will glow. In all of these values, একটা value সেটা ম্যাচ করে, সেটা কোনটা?
6.
Plus 6. So I'm going to give a tick over here. This is just by process of direct calculation, not by elimination. And if you look for the red LED here, this is plus 3, which means the red LED will glow, let me write over here, only when the V plus is bigger than plus 3.0 volt. এখানে plus 3.0 volt এর চেয়ে বড় ভ্যালু আছে দুইটা, plus 4 and plus 6. So red will glow for both of these. So essentially এখানে একটা ক্রস হবে। এই হচ্ছে তোমার ফুল টেবিল। Logically, you just have to fill this up by calculating one after another, and you should be filling up this table and get 3 marks out of it. এটা কেন এরকম হয়েছে, কি লজিক খাটা এটা করতে হচ্ছে, তোমাকে এখানে কিছু রিজন স্টেট করতে হবে না। This is just a checking that whether you understand how the op-amp works or not. এটা ফিল আপ করার প্রসেসটা বুঝা গেছে সবার?
Ji, sir.
Yes, sir.
Okay. It's a pretty simple question as long as you understand what you are supposed to do. আমি গ্রাফের একটা কোশ্চেন দেখাতে বলে একটু শান্তি পেলাম, আমি গ্রাফের একটা কোশ্চেন দেখাতে বলে এখান থেকে সরে যাব, কিন্তু গ্রাফের কোশ্চেন তো পাইতেছি না। এই যে ওই যে এলইডি টাইপের কোশ্চেন, যেমন এখানে ওরা দেয় নাই, কি বলে, রেজিস্টার দেয় নাই।
স্যার ক্যালকুলেশনটা একবার একটু কি দেখানো যায়, মানে আপনি ডিভিশনটা কিভাবে করলেন ভোল্টেজের? লাইক এট ফার্স্ট 5 ভোল্ট ছিল, রাইট? ইনভার্টিং ইনপুটে দিতেছি।
না 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 না, এই অপ এম্পের ইনভার্টিং ইনপুটে সবসময় +5 আছে, এই অপ এম্পের ইনভার্টিং ইনপুটে সবসময় +3 আছে। These two are fixed values. I'm going to only change V in, which means I'm going to change the value of this thing goes straight over here, and a junction comes up and inputs over here. So I'm going to change the value of V in. V in this case for both of them are working as V plus for both the op amps.
জি স্যার। তো স্যার 2 ভোল্ট যদি প্রথমে হয় তাহলে 5 - 2 হচ্ছে 3 ভোল্ট।
না, 2 - 5 মানে হচ্ছে -3 volt, because you're going to do V plus minus V minus, you're not going to do V minus
আচ্ছা
minus
আচ্ছা
V.
আচ্ছা আচ্ছা আচ্ছা।
বুঝে গেছে?
And sir, it for the green one it has to be greater than +5 volt, but like
Beautiful. That's
because
what I wrote.
স্যাচুরেশনটা মানে স্যাচুরেশন দিয়ে আর কি কনসিডার করতে হচ্ছে, রাইট?
Nah, not essentially saturated. In this case, it will be saturated for sure because there is the feedback loop. So it will be by default saturated. We are figuring it out because the diodes are aiming downwards. So these diodes will only glow if the output is positive, so that the current will be flowing downwards. If these diodes were aiming upwards, then we will be expecting a negative output over here for it to glow. So the duration of the diodes is telling us what kind of output should we have for them to glow. And then from there, we decided that what kind of V plus should we require for them to glow. So first, the orientation of the diodes leading to the output type plus or minus, that leading to the comparison values.
So sir, output voltage must be greater than the V in here. Like so, sorry, then the what will I say? Then the voltage given to the inverting
V plus should be bigger than the V minus. That's what we're trying to say.
Yeah.
ঠিক আছে, আমি গ্রাফের একটা কোশ্চেন খুঁজে পাইছিলাম, গ্রাফের একটা কোশ্চেন খুঁজে পাইলে শান্তি মতো মুভ করা যেত। গ্রাফের কোশ্চেন নাই এখানে, একটা না থাকলে এখন আমাকে কোশ্চেন পেপার ঘাটে একটা বাই করতে হবে, থাকার কথা অ্যাকচুয়ালি।
Calibration curve, sir.
হ্যাঁ, এই যে পাওয়া গেছে, পাওয়া গেছে না? হ্যাঁ পাওয়া গেছে, পাওয়া গেছে, হ্যাঁ পাওয়া গেছে, আই থিঙ্ক পাওয়া গেছে। হ্যাঁ ঠিক আছে, এটা একটা গ্রাফ, ঠিক আছে। এই কোশ্চেনটা আমি সিলেক্ট করে নিয়ে যাই, সিলেক্ট হও। এই কোশ্চেনটা প্রথমে দেখো খুব সিম্পল জিনিসপত্র। Operation amplifier may be used as a part of the replacement of electronic sensor. State 4 properties of an additional op amp. So you just state 4 properties without spelling mistakes, score 4 marks. As simple as that. কোনো হাবিজাবি নাই, এগুলা জাস্ট তোতা পাখির মতো লিখবা, তোতা পাখির মতো মার্কস পাবা। আচ্ছা, এই কোশ্চেনটা আমরা কিভাবে সলভ করবো আমি কোশ্চেনটা দেখাচ্ছি তোমাদেরকে। জাস্ট মোমেন্ট, get rid of all of this. Have a look. A comparator circuit incorporating an ideal op amp is shown in figure 9.1. So we have the circuit over here. The variation with time t of the input potential V in is shown in figure 9.2. So we have a graph over here. On the axis of figure 9.2, on the axis of figure 9.2, draw a graph to show the variation of the with time t of the output potential V out. So আমাদেরকে V out আঁকতে বলছে। আঁটানোর সুবিধার জন্য আমি সার্কিটটাকে ডান পাশে নিয়ে আসতেছি যাতে করে আমরা দুইটা জিনিসকে একসাথে দেখতে পারি। I think that will be better visible. সার্কিট দেখা যাচ্ছে সবার?
Yes, sir.
আচ্ছা, এই জিনিসটা খেয়াল করো, there is no feedback loop, which means the output will be always saturated, and in this case the supply voltage is labeled as ±5 volt. So you're always going to have ±5 volt. একটা জিনিস খেয়াল করো, in this case V plus is fed directly from ground, তাহলে V plus এর ডিফল্ট ভ্যালু কত? 0, ঠিক আছে। V in টা হচ্ছে V minus in this case as far the circuit shows, so which means V out equals to gain, which is practically infinite. Not practically infinite, I mean for ideal op amp it is infinite, it is considered to be an ideal op amp. into 0 minus V in. এই জিনিসটা দেখো বুঝো কিনা। V in এটা কেন হলো? Because in this case V in was only fed into the V minus. So আমি V minus এর জায়গায় V in লিখছি, V plus এর জায়গায় 0 ভোল্ট লিখছি। এই ইকুয়েশনটা কি বোঝা যাচ্ছে এভরিওয়ান?
জি স্যার।
কনফিউশন থাকলে বলো, আমি আর ডিটেইলসে বুঝাবো, বাট ইটস ইম্পর্টেন্ট দ্যাট ইউ ফার্স্ট আন্ডারস্ট্যান্ড দিস ইকুয়েশন বিকজ দিস উইল লিড আপ টু দ্য ওয়ার্কিং ফর দিস ওয়ান। হ্যাঁ, জিনিস খেয়াল করো, have a look. Whenever the input voltage is positive, when this one has a positive value, the total subtraction value would be somewhat negative. Whenever this thing has a somewhat negative value, your output will be negative supply because it will become saturated and take the negative value. And on the supply negative maximum hoche -5, which means for this entire loop, for the duration when the supply voltage was on the positive side, the output will be fixed at -5. And it will be maintained at -5 for this entire duration, which means this will lead to the circuit which is gonna look like this. এখানে তো -4, so -5 হচ্ছে মনে করো A2. This goes up to the 8th division, so I'm gonna put it up to the 8th division. এটা এই পর্যন্ত 8th division-এ থাকবে। The moment, আচ্ছা, consider this as a horizontal line through the middle. It's very difficult for me to pause at the correct point. The moment this input is becoming negative, then this is becoming negative. So minus minus plus হয়ে গেলে আমাদের total input টা হবে হচ্ছে positive. In that case, output should become positive and it will become saturated positive output, which means from this point it should become +5, fixed +5. So সেটা হচ্ছে আমাদের এই 8 division থেকে শুরু করে পরবর্তী চেঞ্জ হওয়া পর্যন্ত, A2 পর্যন্ত। And for the in between gap, this should be a perfect vertical line. So this is the location where the voltage will take a jump. এখান থেকে এবং তারপর এখান থেকে এই পর্যন্ত হচ্ছে +5 এ ফিক্স থাকবে, এখান থেকে আবার -5 এ ফিক্স যাবে এই পর্যন্ত। And then ওই ক্রসিং হওয়া পর্যন্ত -5 এ ফিক্স থাকবে, and that's how it's gonna convert. বললাম বুঝা গেছে কি? And it's gonna, you have to complete this up to this part. এখানে কোশ্চেনের অবস্থা কি হচ্ছে দেখো, on the axis of an amplitude draw a graph to show the variation in time t of the output of potential V out. So তুমি এটাকে কতটুকু পর্যন্ত আঁকবা? তুমি আঁকবা হচ্ছে এই ডিভিশন পর্যন্ত। তার মানে হচ্ছে আমি যদি এটাকে ফার্দার কন্টিনিউ করি, মনে করো আমি রাফলি হাত দিয়ে কন্টিনিউ করতেছি, এটা উপরে উঠবে, এখানে পজিটিভ হবে, তারপরে এই বরাবর নিচে নামবে, নিচে নামার পর এটা যেখানে শেষ হয়েছে, এটা শেষ হয়েছে এই ডিভিশনের আগ পর্যন্ত। সো তোমার লাইনটা এখান থেকে -5 পর্যন্ত তুমি এই পর্যন্ত কন্টিনিউ করে শেষ করবা। কোশ্চেনে যতটুকু পর্যন্ত দেখানো আছে তুমি ততটুকু পর্যন্ত কন্টিনিউ করবা, দ্যাটস ইট। ডোন্ট ফিনিশ রাইট হিয়ার, ডোন্ট এক্সটেন্ড ফার্দার। যতটুকু দেখানো আছে অতটুকু পর্যন্ত। বুঝা গেছে কেন স্কয়ার গ্রাফ হচ্ছে? এটা কি বুঝা গেছে সবার?
কারণ স্যাচুরেশন,
বিকজ ইট উইল অলওয়েজ বি স্যাচুরেটেড। কেন রিভার্স হচ্ছে সেটা বুঝা গেছে?
স্যার রিভার্সের ব্যাপারটা বুঝি নাই, মানে প্রথমে নেগেটিভ থেকে কেন?
রিভার্সের ব্যাপারটা আসছে এই ইকুয়েশন থেকে, বিকজ এখানে ভি প্লাসটা হচ্ছে 0 ভোল্ট আর ভি ইনটা হচ্ছে ভি মাইনাস। সো এটা যদি পজিটিভ হয়, সাবট্রাকশনের রেজাল্ট হবে নেগেটিভ, আউটপুট হবে নেগেটিভ, এন্ড ভাইস ভার্সা। সো পজিটিভ ভি ইন গিভিং ইউ নেগেটিভ ভি আউট, negative V giving you positive V out, but always plus or -5, nothing else than that.
স্যাচুরেশনের কারণে এটা রেক্ট্যাঙ্গল শেপ।
হ্যাঁ, বুঝছো তো সবাই? I hope so.
Yes.
আচ্ছা, এরকম আরো কিছু কোশ্চেন আছে, এগুলো আস্তে আস্তে তোমরা অ্যাটেম্প করতে থাকলে পারবা, আর যা যা না পারবা সেগুলো আমি তোমাদের দেখাবো না পরে। যেমন এখানে একটা ভোল্টমিটার রিডিং এ দিছে, সেটা ক্যালিব্রেশন রিলেটেড একটা কোশ্চেন। এখানে তোমাদের অ্যাকচুয়াল আঁকতে বলছে যে তোমাদের এই নন ইনভার্টিং ইনপুট কিভাবে হবে, নন ইনভার্টিং অ্যাম্পলিফায়ারের ফিডব্যাক কানেকশনটা কোথায় কানেক্ট করতে হবে, to actually physically draw this thing. This is also a similar circuit, যে 15 voltage gain হইলে, আচ্ছা এটা অ্যাকচুয়ালি তোমাদের দেখানো দরকার, এটা একটা ভালো সার্কিট। I'd like to show this as well. এটাকে ডিলিটই করে দেই, এটা হুদাই এখানে আছে, ডোন্ট সেভ। আচ্ছা, ওভারল্যাপ করে দিলাম দেখার সুবিধার জন্য। আচ্ছা, আগে আমরা এই সার্কিটটা ফিল আপ করি। কোশ্চেনে বলছে হচ্ছে কমপ্লিট দ্য সার্কিট অফ সার্কিট ডায়াগ্রাম ফিগার 9.1, লেভেল দ্য ইনপুট এন্ড দ্য আউটপুট। আচ্ছা, এখানে আমাদের এটা হচ্ছে একটা নন ইনভার্টিং ইনপুট, নন ইনভার্টিং অ্যাম্পলিফায়ার। সো আমাদের ফিডব্যাক ফ্র্যাকশনটা হচ্ছে এইটা। সো আই এম গোনা ড্র ফ্রম হিয়ার থ্রু হিয়ার, প্রেফারেবলি ইউজ রুলার ইন ইওর অ্যাকচুয়াল এক্সাম। আর এখান থেকে এখানে অ্যারো দিবা, label this one as V in. That's basically it. That's the circuit. Circuit আঁকা হয়ে গেছে। Calculate the resistance of ours to the non-inverting amplifier has a voltage gain of 15. So এখন 15 gain হতে হলে আমাদের ইকুয়েশন খুব সিম্পল। 15 equals to 1 plus 12 into 10 to the power 3 divided by R. এটা হিসাব করে দেখা তো R কত আসে। Twelve into 10 to the power 3 divided by 14.
স্যার গেইন 15
বলে দিছে কোশ্চেনে।
860, sir, approximately.
857.14। আচ্ছা, আমি 857 লিখলাম। 12 কিলো ওহম তো 2SF, তোমরা চাইলে 860 লিখতে পারো, আমি 857 লিখলাম, সমস্যা নাই। 857 ওহম 3SF ওরন হার্ট। আচ্ছা, এর পরের পার্টটা হচ্ছে আমি যেটা নিয়ে ইন্টারেস্টেড। পরের পার্টটা খেয়াল করো, পরের পার্টটাতে কি বলছে। অন ফিগার 9.2, draw a graph to show the variation with input potential V in of the output potential V out. You should consider input potentials in the range of 0 to plus 1 volt. You should consider input potentials in the range of 0 to plus 1 volt. আচ্ছা, তার মানে হচ্ছে আমরা এখানে ইনপুট হিসেবে দিতেছি হচ্ছে প্লাস 1 ভোল্ট।
In the range, sir, 0 to.
আচ্ছা, আমাদের গেইন যদি হয় 15, আমরা যদি প্লাস 1 ভোল্ট ইনপুট দেই, তাহলে তো আমাদের আউটপুট ফিক্সড প্লাস 9 হওয়ার কথা না। এটা তো হইল না তো। আমার হিসেবে তো এটা খুব সিম্পলই হয়, এটা তো জাস্ট এই বরাবর একটা স্ট্রেট লাইন আঁকলে হয়ে যাওয়ার কথা। যে
স্যার নেগেটিভ ফিডব্যাক সহ আঁকতে হবে না?
ফিডব্যাক সহ আঁকলেও তো স্যাচুরেশনই
ও
হচ্ছে।
জি স্যার।
এখানে তো আমরা স্যাচুরেশন অ্যাভয়েড করতে পারতেছি না, বিকজ আমাদের গেইন আছে 15। আমরা যদি প্লাস 1 ভোল্ট ইনপুট পটেনশিয়াল দেই, প্লাস 1 ভোল্ট ইনপুট পটেনশিয়াল দিলে তো আলটিমেটলি আমাদের গেইন আসতেছে হচ্ছে প্লাস 15। প্লাস 15 তো আর হবে না, সো প্লাস 9 এ শেষ হয়ে যাওয়ার কথা। ও আচ্ছা, না সরি, এটা তো ভিএনএক্স, এটা তো টাইম এক্সিস না, এই তো ভুল করছে এই জায়গাতে। সো এখানে 0 থেকে আস্তে আস্তে জিনিসটা বাড়তেছে, ঠিক আছে, খেয়াল করো। 0 থেকে আস্তে আস্তে এটা 1 এ বাড়তেছে। এখন তুমি একটা জিনিস বুঝো, ইয়া এক্স্যাক্টলি, বিউটিফুল। দিস ইজ এক্স্যাক্টলি হোয়াট আই ওয়াজ ট্রাইং টু গেট এট। দিস ইজ নট টাইম এক্সিস, দিস ইজ হোয়াট এক্সিস। এক্সিসটা কি? ইনপুট এক্সিস। সো তার মানে হচ্ছে আমরা ইনপুট পটেনশিয়ালটাকে আস্তে আস্তে 0 থেকে বাড়াইতে বাড়াইতে প্লাস 1 করব। আর 0 থেকে যখন প্লাস 1 করব, তখন আউটপুটটা কিভাবে চেঞ্জ হবে? আউটপুটের ম্যাক্সিমাম ভ্যালু হচ্ছে 9, আর এক্স্যাক্টলি প্লাস 1 ভোল্টসে আমাদের আউটপুট হওয়ার কথা হচ্ছে 15, কিন্তু প্লাস 15 তো হবে না, কারণ আমাদের সাপ্লাই দেওয়া আছে কত? 9। বুঝো? তার মানে যতক্ষণ পর্যন্ত as long as the input voltage is such that the output is supposed to be 9, it will have an uniform increase. The moment that value of the input would be crossed, so that it has to be bigger than 9, it will not increase any further. So what we have to do, the part that we have to find out, that exactly for which input voltage V out equals to 15 into V in, এই V in টা কত হয়, so that this output voltage is plus 9 volt. This is what we need to calculate out. 15 into Vin. এই Vinটা কত আসে? 0.6 plus 0.6 volt, which means as long as the input would be increased from 0 to 0.6, our output would be increased from 0 to 9. And এখানে 9টা হচ্ছে exactly এই পর্যন্ত, কতটুকু পর্যন্ত? দেখো, these people have given this graph up to 16 so that kids who do not understand the idea of saturation might actually pull this all the way up to 15. But that's not the case. You cannot have the output reaching up to 15 because your supply is limited up to plus 9. So that's the maximum you can have. So at 0.6 input, you can have a maximum output voltage of 9 volts. So let me just zoom in a little bit. It'll be easier for me to draw. So this is our 8, this is our 10. 9 would be at the halfway mark of 0.6. So this is my point. Just to convince your examiner of the fact that you know your thing, you might as well give a dot circle over here, highlight this point, so that the examiner would know that you calculated this out. You can also keep this calculation beside the graph, but examiner will not necessarily mark you for this, examiner will mark you for this intersection point. You don't have to erase this calculation, but if you feel like erasing, you can do that as well. Don't, I mean, that really doesn't matter much. This would be a perfect straight line. As long as this is increased uniformly, this voltage will also increase uniformly. So in this case, for each of the value of the input, you are having a 15 times increase of the output voltage. As long as your input voltage reaches up to the value of 0.6 volt. The moment it becomes 0.6 volt, then it will not increase anymore. From this point onwards, this will remain as plus 9, and this graph is finished like this. This is the graph that they are expecting out of you.
স্যার এখানে যদি মানে ভি মানে ইনপুটে যদি আমাদের আর কি 9 ভোল্ট, সরি আমি যদি সাপ্লাইতে যদি স্যার 9 ভোল্টের বেশি থাকতো, আই মিন 15 ভোল্ট থাকতো ধরেন, তাহলে কি আমাদের আউটপুটটাও ইনক্রিজ করে 15 ভোল্ট পর্যন্ত যেত না?
যাইতো, ইয়েস। সেক্ষেত্রেও আমাদের যদি আউটপুটটা 15 ভোল্ট থাকতো, ফর এক্সাম্পল মানে সাপ্লাই, তুমি বলতেছো যে আমাদের এই সাপ্লাইটা যদি লেটস সে প্লাস 15 ভোল্ট এদিকে মাইনাস 15 ভোল্ট এরকম হইতো, দিস ইজ হোয়াট ইউ আস্কিং?
হ্যাঁ হ্যাঁ, ওইটাই।
যদি এরকম হতো তাহলে আমাদের গ্রাফটা 15 পর্যন্ত ইনক্রিজ করতো। সেই কেসে এটা শুধু একটা স্ট্রেট লাইন হতো, বাট দ্য গ্রেডিয়েন্ট উড বি এক্স্যাক্টলি সেম। সো ইউ উড হ্যাভ আ স্ট্রেট লাইন জাস্ট লাইক দ্যাট all the way up to 15.
কিন্তু স্যার তখন আমার ভি গেইন যদি মানে যদি 15 ভোল্টের বেশি হতো বা কম হতো।
কোনটা?
মানে ভি গেইন স্যার যেটা।
What do you mean V gain?
I mean the gain in voltage.
Output?
এখানে 15 ভোল্ট ছিল না স্যার গেইনটা?
Gain is not voltage, gain is a number. Output voltage or input voltage is volts. Gain is the multiplication factor by which your input will become magnified. So in this case, gain was 15, yes. Gain was 15.
ওইটার থেকে যদি স্যার বেশি হতো,
for example, give me a value.
For example স্যার ধরেন 20 ধরলাম।
Okay, let's say this is 20 and the supplies are how much? এরকম?
হ্যাঁ স্যার।
আচ্ছা,
মানে plus 15 minus 15.
If the gain was supposed to be 20 and the supplies are plus minus 15 volts, which means the maximum saturation volts can be up to 15 volts. So we have to calculate and find out, is it possible for us to accommodate this? And তুমি চিন্তা করো যে যখন আমাদের input 1 volt হবে, when the input voltage is 1 volt, then the output mathematically is supposed to be 20 volt, but 20 volt is not possible to achieve because the supply is limited to plus minus 15, which means we will reach saturation before the input reaches to 1. So we have to calculate the value of the input, relevant input, in this exact same of calculation set that we have done over here. So in that case, আমি যেটা লিখতে পারি সেটা হচ্ছে, for that scenario, maximum output is plus 15 volt, which is equals to 20 into Vin, and the output is plus 15. So এখান থেকে তুমি Vin calculate করে দেখো কত আসে।
0.75 আসবে মনে হয়।
3/4, 0.75 plus 0.75 volt, which means whenever the input will be 0.75 volt, the output is supposed to become 15, and from that point further onwards, it will be stuck at plus 15 volts. So in that scenario, our graph, if I try to draw that with a different color, maybe if I try, let's say green, at 0.75 will reach 15. So at 0.75 will reach 15. So this will be my point. So this will increase from 0 all the way up to here, and then from here we'll have saturation like that. বুঝা গেছে?
জি স্যার। স্যার এমনিতে ইনভার্টিং অ্যাম্পলিফায়ার হোক বা নন ইনভার্টিং হোক, লাইক ইট ডাজন্ট ম্যাটার, সাপ্লাই ভোল্টেজ যতটুকু থাকবে ওইটুকুতে লিমিট, রাইট?
Saturation and limit supply voltage is সমান, yes, but inverting and amplifier, non-inverting amplifier property হচ্ছে যে একটাতে ভোল্টেজের আউটপুটের পোলারিটি রিভার্স হয়, আরটাতে আউটপুটের পোলারিটি রিভার্স হয় না। নন-ইনভার্টিং ইনপুটের মানে নন-ইনভার্টিং ইনপুটের ইকুয়েশন আমাদের কোনো মাইনাস সাইন নাই, সো পজিটিভ ইনপুটের জন্য আমাদের আউটপুটও পজিটিভ হবে, বাট ইনভার্টিং অ্যাম্পলিফায়ারের জন্য উল্টায় যায়। ইনভার্টিং অ্যাম্পলিফায়ার ইকুয়েশন একটা মাইনাস সাইন আছে।
স্যার এরকম গ্রাফ আঁকতে গেলে আমাদের নেগেটিভ ফিডব্যাক যদি দিয়ে দেয় তাহলে ওটাকে কনসিডার কেন করা লাগবে?
করছি তো, নেগেটিভ ফিডব্যাক কনসিডার করছি বলেই তো আমাদের এই ইকুয়েশনটা দিয়ে আমরা গেইন হিসাব করতেছি। আমরা তো বেসিক কোর যে ইকুয়েশন ছিল, দ্য বেসিক গেইন অফ দ্য আইডিয়াল অপ অ্যাম্প, হুইচ ইজ প্র্যাকটিক্যালি ফর অ্যান আইডিয়াল অপ অ্যাম্প দ্য গেইন ভ্যালু ইজ ইনফাইনাইট, আমরা তো ওটাতে ক্যালকুলেশন করতেছি না। This equation was made considering the negative feedback, which came through a series of calculation, which I showed you in an earlier class. This equation set came into existence by considering the effect of negative feedback.
Sir, but গ্রাফে কি আসলে ইফেক্ট করতেছে এটা? Somehow, like I am not being able to get that part. গ্রাফে কোনো ইফেক্ট পড়ে নাকি নেগেটিভ ফিডব্যাকের or not?
What kind of effect are you expecting that is not fulfilling your expectation? What change do you expect to happen?
Sir, নেগেটিভ ফিডব্যাকে আমরা একটা লাইক অ্যাড করতেছি না প্লাস একটা ভোল্ট,
হ্যাঁ,
on the Vin basically.
Yes.
So isn't that supposed to give a rise in voltage more than the normal?
What do you mean by rise in voltage?
মানে V output স্যার কি, মানে স্যার V আউটপুটটা কি বেশি আসার কথা না ইন দ্যাট কেস?
আমি প্রথম থেকে বলে আসছি যে নেগেটিভ ফিডব্যাকের পারপাসটা হচ্ছে ভি আউটটাকে কমায় নিয়ে আসা, বড় করা না, so that we can avoid saturation.
সো এখানে বেসিক্যালি আমাদের ইনিশিয়াল পার্ট স্যাচুরেশন রিচ করার আগ পর্যন্ত ওইটা নেগেটিভ ফিডব্যাকের কারণে আর কি বেসিক্যালি রিডিউস ছিল।
Yes, you can say that. যদি নেগেটিভ ফিডব্যাক এক্সিস্ট না করতো তাহলে এই গ্রাফটা শুরু থেকেই +9 বা +15 এ জাম্প করতো।
ও এই যে এখানেই ব্যাপারটা আছে, ঠিক আছে।
আচ্ছা, বুঝছো এখন?
হ্যাঁ স্যার, বুঝতে পারছি।
Beautiful.
So saturation does not occur until 0.6 VA.
For this circuit, yes, this circuit can handle up to saturation up to I mean this blue lines or the red lines that I've drawn, which was based upon the gain of 15. This could handle up to 0.6 for a +9 volt.
So negative feedback circuits are used to avoid saturation, but only up to a certain point.
I mean, it all depends on your choice of these resistors. For example, in this case, if you know from your experience that the input is supposed to have a range of 0 to +1. Let's say you know this from earlier, that this is the support type of input variation that I'm expecting. In that scenario, I would preferably choose this pair of resistors in such a way so that I could avoid saturation.
So it depends on the resistors.
Because the choice of these resistors are in my hands. So if I want to avoid saturation, this is what I would be doing. But if for some purpose, if there is a reason that I would like to detect a T tilt point that I would like this whole thing to become saturated for whatever reason at 0.6, I could also choose this kind of values as well, that it would give me a proportional increase up to 0.6 volt, but for the later part it will become flat at the limiting value. If that is the kind of output that for some circuit that you require to have, you can also design it in that manner, no big deal. It depends upon what you want to have. You can design your resistance values in that way and your supply voltage in that manner.
So it's dependent on the source voltage.
Yeah, exactly. I mean, without the negative feedback, I mean, without this feedback pathway, we do not have that control. Anytime the V plus and V minus have some difference in between them, output would always become saturated at the terminal value or at the positive maximum or the negative maximum. But if you have the feedback voltage, because of the feedback voltage, you can achieve this proportional increase. It is not starting to give you full saturation from the very beginning, which Shubhro just asked, which is a pretty nice discussion. Yes.
Understand, sir.
Beautiful.
So we can even design a circuit which is high avoidance to saturation.
Exactly. We can control the point up to which we want to saturate, we want to avoid, by choosing these resistors properly, or we can choose the value of the supply voltages or a pair of both of them, depending upon what kind of output are we expecting out of this circuit.
So this means যে আমাদের এই যে সব সার্কিটের main role is to of the negative feedback is to control the gain, right?
Yes, or to be more precise, lower the gain or limit the gain.
জি স্যার, কারণ অন্য সময় তো এমনিতে সব সময় ইনফাইনাইট গেইন থাকবে in an ideal op amp, right? ওটা আমরা লোয়ার করে দিচ্ছি আর কি এখানে।
Exactly. আচ্ছা, আমরা নেক্সট রেগুলার ক্লাসে ইনশাআল্লাহ আমরা স্টার্ট করতে পারবো, রিমোট সেন্সিংটা স্টার্ট করব ডিসকাশন। আর হচ্ছে এখন আমি অফিশিয়ালি ক্লাস ক্লোজ করে দিচ্ছি, আল স্টপ দ্য রেকর্ডিং। তোমরা যারা স্কুলের পরীক্ষার জন্য প্রবলেম দেখাবা তারা স্টিক করো, আর যারা থাকবা না তারা চলে যেতে পারো। থ্যাংক ইউ ভেরি মাচ। আই এম স্টপিং দ্য রেকর্ডিং।